Okay, yeah, you see, we are still in the jungle, but now we find a treasure, and there are people around us that make him bigger. So welcome back to Albert's travel diary. We continue our pleasant VuFind adventure, starting with a short overview of our project, the current state, and then I will show scaling opportunities for VuFind with Docker and Kubernetes. In the second part, Ying talk about SolrProxy component and a possibility to integrate all open LX data. So let's start, introduce Albert. Okay. The, Albert is a discovery system developed by the KOBV, the cooperative library network Berlin-Brandenburg, which is an association of all university libraries, all public libraries, and many special libraries in this region. Albert is developed roughly about 11 years and is based on the concept of the library of the Helmholtz Center Potsdam, a German research center for geoscience, the develop and pilot user of Albert. Albert has two kinds of front ends: topic-based search portals, which selected with selected data sources and/or excerpts and format Mark 21 on a topic of different institutions. For example, our KOBV portal that provides nearly all metadata of catalogs in the region Berlin-Brandenburg, and institutional front ends that provide access to metadata of multiple individual sources that are relevant for the institute. For this kind of front end, there will be supported different data formats. And so it looked like now Albert has a modularized backend for data processing in Apache Solr in the Solr cloud mode as a search index, and VuFind as a front end. And we have 13 project corporations, and 10 are now running on VuFind. And the last 3 are the portals, and there we will work on. Then we have a team of 5 full stack DevOps and 1 project manager. Yes. So what are the Albert key point features? We have the integration of search indices as tabs. For the institutional instances, we have the institutional index, and for the portal, the portal index. And then we have a tab with the article index with data from Crossref and from ein gemeinsamer Verbindeindex for the German interlibrary loan. And we have our own design with barrier-free components, the high contrast view. And we have display of hierarchies of records, integration of classifications, for example, the Regierungsbürgerverbund Klassifikation, RVK, and the BTU has also some own classification that we display, and special availability with custom real-time script for diseases, and then we can the availabilities records or our availability database that will regularly updated. Then we have some account functionality for these via NSIP and in cooperation with the Bavarian library network. And we have the connection to a Solr code with our own scheme for now. So this is our timeline for Albert, the VuFind project. It started in 2021. What I talked about is last year, so I won't go into details here and start direct in the first quarter of 2024, where we made a first release with VuFind for our project partner, the University of Applied Science in Potsdam, FAP. In following 2 quarters of 2024, we released VuFind for project partners, the European University Viadrina in Frankfurt, and the German Aerospace Center, and the Brandenburg University of Technology and Cottbus-Senftenberg, BTU. In the fourth quarter of the 2024, we made a second release of the Technical University of Applied Science, Wildau, to create a connection of the integrated library system KOHA. But until now, the core is working with our NZIP component driver in VuFind to keep the compatibility and keep it simple to migrate. Soon we want to migrate that flight to the VuFind standard. Furthermore, we start a project with EVV to update our VuFind version from 7.1 to 10.1, focusing the instance of Brandenburg with you, which we release in the end of the first quarter this year, together with the instances of the Leibniz Institute for Science and Mathematics, the EPN, and the Geomar Helmholtz Center for Ocean Research, Kiel, which we are in the release pipeline for a while, such that we decide to update these to version 10.1 as well and release them after a short test period. In the second quarter this year, we decide to become more familiar with the RecordManager to consider whether we can replace some backend processing of now. Second point, we start to migrate to VuFind of our KOBV portal. This quarter, we released our last 2 institutional instances with VuFind and updated all previously released instances to version 10.1. Additionally, we start to evaluate Solr's collapse and expand feature with the goal to replace our existing backend deduplication processing. For the last quarter this year and first quarter next year, we plan to finalize the migration of the KOBV portal and go further with the evaluation of the RecordManager and the integration of Solr's collapse and expand feature. To migrate our backend, especially a Solr scheme, more to standard VuFind, we decide to create a default VuFind in our infrastructure Kubernetes for evaluation. To achieve this goal, we containerize VuFind. We decide to use a lightweight infrastructure with Alpine Linux and lightheaded HTTP web server and modularize of each part, PHP, lightheaded MariaDB, and Apache Solr. This will look like this. There are 5 containers, and yes, we have all the same base image that makes it easy to upgrade. This will be now in Kubernetes. This will look like this, and on the left side, we see some ingress controller which manages the external communication. And yes, we have some namespace that were used to include our resources that the VuFind uses, and we have a config map which provides the key value pairs that will be provided as environment variables in the container, like VuFind modules, cache dir, Solr URL, and so on. And the secrets are analog to the config maps that secrets like database authentication and service manages the load balancing in Kubernetes and the persistent access to the pods. And the pods groups 1 or more containers which should run together as a single logical unit and share network and storage. A pod is also the smallest deployable unit and can be scaled. And for VuFind, we encapsulate lightheaded HTTP and PHP FPM together so that they are in the local network. And for VuFind, database and Solr have their data stored in a persistent volume and mounted in the containers. There's also 2 sidecar temporary pods that initialize the Solr volume and do the import of the data. So you can try it out. We have this running with a default VuFind in 10.2 and tested with Debian 13 and also running in Windows subsystem Linux. Yes, there are 2 setups. The first is a Docker, and it possibly also works in Podman. And then we have some light-bright Kubernetes distribution, K3D. It's based on Docker, and you can also run it there. And yes, it's a small example sample data with 2000 records. And yes, it's experimental proof of concept. You can try it. And so I give to Ying SolrProxy.
Hello, everyone. And
so yeah, just sorry. Yes, we are also evaluating the RecordManager with Kubernetes, but it's work in progress. As you see it on the left side, yes, it's not clear that we use this structure in the future, but we have some pod with a PHP helper that needs to be because of the persistent volume will need it and for the jobs, and so we try to integrate it, but it's run, but not so for the public now. So.
okay. Hello, everyone again. And we prepared two topics today, continue talking about our infrastructure. And one is what I will talk later. One is the on-the-fly enrichment of OpenAlex data into the VuFind. And but now we start with the part that something beyond VuFind, that is our SolrProxy. And as Martin already introduced, we have a central Solr cloud, and we have multiple instances, and all data sources are indexed into the Solr cloud, ready for search. And on the other hand, each instance has their own requirement on the data and its own holdings. So we are a colleague of KOBV thinking about how we solve this problem, and they started to implement the SolrProxy, which acts as a gatekeeper between the Solr cloud and instances, VuFind instances, and with authentications token and so on. Later on, we have other features on the SolrProxy, which is we can customize some Solr parameters that to fulfill the requirement of the individual libraries, such like they can, for example, for the large data collection that may contain 20 million records, and we just processing the data once, and then the instances will just using filtering features of the Solr and configure these filtering features in the SolrProxy to get a subset of the large database, a large data collection. It works, for example, for ebooks collection as well for cooperative collection, online articles as well. We will have a inside look later. And we can also put some flexible boosting and fine-tuning parameters in the SolrProxy, and to let instances to reorder their holdings, books maybe at the beginning to be displayed for the user, and the national license ebooks will be later, and such stuff. Maybe for each instances, they have their different requirement. Mm-hmm. And certainly they have, the holdings are already differently. So otherwise, we provide with, we don't have, we use as well the external database, which is the German interlibrary loan index, GVE, and that is the general index. We have no influence on it. We get just response from the default index. And if the data is not in the form that we want to display to the user, and we have to make some special logics. And this happens already as well in SolrProxy size. For some of us use scenarios, is the SolrProxy not must have, but it is a nice have. And this year we made some improvement on the operation of SolrProxy. For instance, it's deployed in the test and production environment automatically, also in Kubernetes. And yes, I will at the end show you some real-time production data of the SolrProxy. Yeah, how the instances communicate with SolrProxy in Kubernetes, which is very simple, just using the name of the namespace and then the service name of the SolrProxy, and they can communicate. But our Solr is still outside of the Kubernetes, but we plan to move the Solr as well into the Kubernetes cluster. And we use the Helm chart to develop SolrProxy as well, all VuFind instances into Kubernetes automatically. And in the test environment, each push to the repository of develop branch will trigger the deployment of the SolrProxy into the test environment, and which will all test instances will get the current status of SolrProxy. Right. Yeah, SolrProxy basically in the Kubernetes, due to the native feature of Kubernetes, the work balancing there is quite good, and we will also see that in the plots, in the diagrams in live environment. So here is the ebook collection. The ebook collection data flow, and we got the metadata from ebook pool, and ebook collection is some kind of organized by a package ID, and each ebook package ID contains ebooks. Some package has more, some package has less, and right, we got the metadata and index the metadata just once into the Solr cloud, and then we're using the SolrProxy. We're using the SolrProxy here to filter the time set, the subset of the whole collection into the for the instances. There is certainly some instances they want to have the whole ebook collection, and it is as well possible. Yes. And here we see some real-time plots that we can see the requests through SolrProxy are spread among the multiple instances. At the moment, we have 10 Arbeit instances, and we have 12 SolrProxy. And the response time mainly locates between 10 milliseconds to 80 milliseconds, and the mean response time is about 60 milliseconds. And there are certainly some requests which take longer. The maximum response time is 3 or 4 seconds. Yeah, that is the statistic from the Kubernetes, that you can also see that there's a 12 SolrProxy located on 2 Kubernetes nodes, and each nodes are 6 pods on it, and we using the, I forgot to say, we're using the Loki and Prometheus and Grafana to collecting the logs from Kubernetes cluster and make some query on this logging content, and using Grafana to define some dashboards by ourselves in Grafana and to get such plots. And now you can see here traffic of a workday from 6 o'clock to 18 o'clock. I forgot as well to say this is some kind of a heavy traffic time period, 6 hour, something like this. And here is the half day as a 12-hour traffic, and we plotted all time series stacked over each other, that the upper bounds you can tell the sum of all these values. And the upper diagram is the read of the response, the read of a request, that you can clearly see that people works at 8 o'clock, make a coffee break at 11, and then afternoon is very productive time until evening. That is the rate of request. At the diagram below is the capacity requesting that we calculated from the live response time, which means that if the live log the response time, if the response time short, and then the capacity of the requesting at this moment is high, and it is a theoretical capacity. But we want to see that whether our capacity covers the usage of the SolrProxy. And at the moment, if we notice that the SolrProxy not covering the use, we got a very long response time, and then we have two possibilities to scale our component SolrProxy. One is we can increase the replica of SolrProxy in Kubernetes, and the other is maybe more effective to scaling this directly in Solr. Yes. And now we jumped into the second topic about the enrichment, on-the-fly enrichment in VuFind. And yes, but I started this just with a small experiment, and it works quite well. And so we just decided maybe that here to share our experience in the community. And first of all, we have some background of the cross-F workflow in the Arbeit context, and then maybe we introduce OpenAlex, but I'm not sure who knows already OpenAlex data. Okay, not that much. Maybe okay. I have a slide to give a brief introduction, and then. Right, OpenAlex provide as well the API accesses, and you can both as a basic user, which just provide email, and then you can start the API, and or you are a premium user or institutional user that using the API token, API key or authentication key. And at the moment, we are just a basic user, and later on, we have already date with the OpenAlex group and to have a talk that we have interest to become a premium user. So, and a little about the implementation of this on-the-fly enrichment, and at the end, I will show you some examples that for this small experiment. Yeah. Alternatively, the OpenAlex data, if you have enough resource, you can also hosting the OpenAlex data. And we have already done this, which means maybe if we want to have more deeper analysis on the OpenAlex data and the work we are able to host the OpenAlex data by our own already. And this is another story, not for today. Here's the cooperative workflow. You may notice already all Arbeit's data flow looks very similarly, and we try to keep it as simple as possible. And on the other side, you see that we get a cooperative data, and using our own program to enrich the cooperative data with the CDB ID and library holdings information, classifications, and so on and so forth. After enrichment, here is without any OpenAlex data, right? And after this, it is exported and then indexed in the Solr cloud. As well here, we use the SolrProxy, whether just opening the holdings of the library to the VuFind instance, or the complete course of online articles to the instances. There is our library. They want the complete online articles. And for this library, for their user, and we think maybe it is good to enrich the online articles with open access information extra. 3 minutes, okay. And then right. Yes, and then that's why we're doing this on-the-fly enrichment. The basic idea here is during the VuFind processing the records, and that first, the basic idea is we just enriched OpenAlex, the open access information to the records which just displayed in the site. Maybe it depends on the configuration, 20 by default, and then the open access information are just enriched into these 20 records. And if the user click the next page, and then during the loading of the records are the open access information from OpenAlex enriched at the same time into the record. And so right now a little introduction. OpenAlex data is structured by the works, institutions, topics, and authors, and the data sources are from cooperative and archive.org and some others. And there are ebooks, but I think basically in OpenAlex data are more online articles. And at the end, we can see here the cooperative data. There are 34 or 35 almost percent cooperative data has open access location, which is very valuable for our user. And the German national and Alliance license is not included as well, which means if we add the national and Alliance license into the cooperative, and we will have more than 35% open access. And the implementation of this on-the-fly enrichment is is very simple, and we have our foundation record driver, which named this KOBV, and which inherited from the VuFind Solr default, and it has 3 kits, and that is our 3 search tabs. And the online article driver has an extra connector, which is OpenAlex, and we can use this OpenAlex connector to sending the request to OpenAlex. Meanwhile, the processing of the records in VuFind. And then, what information that we can get from OpenAlex? At the beginning, we need the open access details, open access status, open access location, and citation counts, and they have already some citation and relevance graph, which may also interesting for the user as a recommendation. If you search the article and you get as well the all related works at the end. So that's the example. User search Navier-Stokes equation and then get the list here. And if the list displayed on the search interface, which means the on-the-fly enrichment is finished already. And we will get here that an extra fields that tell us it is the closed open access, it is which type is it, is there any URL, and how many citations there. And this is the first enrichment. We need as well a linking field. That is, in our case, is DOE. We are pretty sure that all our online articles with DOE and with this DOE, we can find in OpenAlex the OpenAlex data linking. And yes, after this step, we are not only get the open access information, we save the OpenAlex ID as well, and for the next step to get the related work. Right. And maybe later we will interest some other information from OpenAlex data, and then you can see here there are some green, there are some gold, there are open access, and there are as well some closed open access record. And now, if user click on the details wheel, and you will we will start as well the second enrichment of and the second enrichment is because we already remember the OpenAlex ID, and we can using this ID getting from getting the related work as a commendation to this detailed record. And there are something that we get from the second enrichment, and we are also have the possibility to link the library holdings using DOE, which means all these related work we can write on the fly and check whether, or we just constructed a link to the library holdings. If the open access status is closed. Okay. This is the conclusion. I think maybe I don't have time. Okay. Positive things is it is a really lightweight implementation, and and it's user orientated, and it just enriched what user searched. We don't prepare the heavy data processing in the backend. We just do this small stuff on the front end, and the ranking and filtering there can be influenced by the library, by ourselves. And yeah, there's possibility being this both side coupling using the OpenAlex ID, using the DOE, linking to an external data set and linking back to the internal holdings, and that is the benefit. And yeah, that is also a benefit from the outside development that OpenAlex data doing also some clustering work that making the topic together, and it is as well interesting for us. And we want to support the open science, open data, and open source. The concept, there are some negatives. Well, you cannot using this on the fly enrichment doing faceting. This is not possible, faceting search. And right, it is a certain dependency of the outside data sources outside. And right, it is some workload on the front end. Yeah, I would like give back to Martin for the last two slides.
With Outlook, we want to update to VuFind 11 and migration of our proper front ends, migration of our Solr scheme towards more standard VuFind, and further evaluation of the RecordManager as part of our backend, and further evaluation of data duplication with collapse and expand feature from Apache Solr. Okay, thanks you.